All right, so this is CC2. It's section 2.1.2. Oops. And it's number 2-6. So CC2 2.1.2, number 2-26. So this is a question that's asking us to, it says, which of the following fractions are repeating decimals and which are terminating? Show how you made your decisions. Okay, so this is where if I'm given A, I have to decide whether it's a terminating or repeating. Well, there's a couple ways to look at this. If I can immediately put it, what I look at is can I take 2/5, or excuse me, in this case, 2/15? Can I convert it to something over 10 or something over 100 or something over 1,000 real easily? If I can see that, that's going to help me make it into a decimal real fast. So is that possible? 15 doesn't go into 10, 15 doesn't go into 100, and it doesn't go into 1,000. All right. So that being said, we're going to have to do the division. So I'm going to say 15 into 2. How many times, right? So I start off 15. It's 2 divided by 15. I start off and I have to add a decimal and do the process. 15 into 20 is 1. Remember, the decimal goes up. Put a 0 in front, and I get 15. And then I subtract. I get 5. And then I have to bring down my 0. Okay, so I get 15 into 50. That's 3 times. Multiply, I get 45. Subtract, I get 5. Okay, bring down the 0. Again, 15 into 50 is 3. I'm seeing a pattern here, 45. Already I can see my pattern. I keep getting 3s with a remainder of 5. So every time I'm going to be bringing down another 0, I'm going to be asking myself, how many times does 15 go into 50? And I'm going to keep getting 3. So right there, I see that it's repeating. So for A, we would say A is repeating decimal. And the question wanted us to show how you made your decision. Well, that's how I made my decision. I did the division. Okay, so that's A. B is 11 over 20. Now remember, what did I say earlier? I said if you can get the fraction to be over 10, over 100, over 1,000, then we can make it into a decimal real quickly, a terminating decimal, which I'll show you. What does that look like? So 11/20, that can be over 100, can't it? Because hopefully at this point you are able to see that 20 times 5 is 100. So I'm going to use a giant 1 and multiply top and bottom by 20. Excuse me, by 5, top and bottom by 5. 5 times 20 times 5 is 100. 11 times 5 is 55. So my new fraction is 55 100ths. And remember, reading a fraction is reading a decimal. When it's hundredths or tenths or thousandths, that's why I want to put it over 100. 55 hundredths as a decimal is written as 55 hundredths. So yes, this is a terminating decimal. And how do I know? I just showed you. That's my proof, right? So when it says show how you know, just do the math and show how you know. Okay, C wants us to do 17 over 40. And again, I need to see, can I get this over 10? No, can't reduce it to make it over 10. Can I make it over 100? No, 40 doesn't evenly go into 100. How about 1,000? Let's see, can I make it into 1,000? I might be able to. I think 40 times 25 might be 1,000, right? Actually, I'm going to change that, go 25 times 40, because I got a 0 here. And then I multiply, I get another 0, carry a 2, 8, 2, 1, sure does. So what am I doing? I am showing that 40 can be converted to a fraction over 1,000 by multiplying by a giant 1 of 25 over 25, right? So 25 times 40 times 25 is 1,000. 17 times 25, well, again, I'm going to have to probably do that math on the side here. 17 times 25, that gives me 35, carry the 3. 14 plus 3 is 17. Then put in your place value. 1 times 5 is 5. 1 times 2 is 2, right? And then add those up. 5, 2, carry the 1. We get 4. So 425. So 17 times 25 is 425. So why did I do that? Because I have something over 1,000. So when you have a fraction over 1,000, how would I read this? I read this as 425 thousandth. 425 thousandths is, as a decimal, 425 thousandths, right? So I can see it as a decimal. It is terminating. If you didn't see the way to do it by the giant one, what would have been the other way to do this one? The other way would have been just to take 40, right? 17 divided by 40 is take 17 into, 40 into 17 and do the math. Long division, right? We're going to have to add a decimal. 40 doesn't go into 17, put a 0. 40 goes into, start adding some zeros. 40 goes into 170 4 times. Multiply, you get 160. Subtract, you get 10. Bring down that 0. 40 goes into 100 twice. Multiply, you get 80. You following this? So this would be the other way, doing the long division. Bring down the 0. Now 40 does go into 200 5 times, and that's where it terminates, because then you get a remainder of 0. And sure enough, there's my answer. 425 thousandths was the same thing, just doing long division versus doing it as a fraction. Okay, that's C. So C is terminating. Last one, put it over here, is D, and D is 1/12. So 1/12, I'm not seeing real fast how to make that over 10 or over 100 or over 1,000. So I'm going to go ahead and divide, right? So it's 1 divided by 12. Put the decimal, add some zeros. 12 goes into 10. Nope, it doesn't. So that's going to be a 0. 12 goes into 100. Let's see, that's 8. 8 times. So 8 times 12 is 96. Make sure you're lining up your digits. So I get a 4, bring down to 0. 40, 12 goes into 40, let's see, 3 times. 3 times 12 is 36. Subtract, I get another 4, bring down the 0. 12 goes into 40, again 3 times. I'm going to see, I see the pattern here. Do you? We end up with 4 again. If I bring down another 0, I have another 40. And I would continue to get 3s every time. I get the same remainder every time. So at that point, I see I have the 3 repeating. So D, I would say, is repeating. And how do I know? Look at my math. That's how I know. Repeating decimal. And I prove it by showing the work. All right, there you go.